Hello again. We are back with our last panel today. Last but not least, we will discuss the topic how we could authentically design outerwear to be fully biodegradable. It's a really interesting question. So I would like to pass the word to Charles. Hello, Charles.
Hello, Astrid. How are you?
Hi, how are you?
I've had an easy day compared to you. It's been a very busy day from your point of view.
Okay, so maybe you can give a short introduction to all the attendees. So I will pass to you and have a really interesting discussion.
Thank you. Thank you. I'm Charles. For those people who don't know me, I teach at a small London college, but I'm the person with my fingers crossed because this is the first panel that we're running through performance days. So we hope the technology is going to hang in there. I know right at this moment, I've got Aaron in Taiwan about to go to bed. I've got Lucy in New Zealand who got up at 4 o'clock in the morning, and Matt over in the US who are all tuning into us. And that's the wonder of performance days. And I regularly ask people to see what the more controversial subjects or subjects that they don't understand are. And the subject of biodegradability has shot up in the last year or so. And I know this panel will not answer every question that every viewer has, but it will give an insight to some interesting things that I've come across whilst researching the topic. We know that there's a very big trend towards environmental better practice. I've only got to look at something like Polartec, who now have 50% recycled content in their normal fleece, and they don't even label it as such. I look at technology like Sympatex's membrane, which uses a recycled PET. So there is a massive trend, and biodegradability is hooking on the back of it. And I fear that the biodegradability means everything to everybody else. And we are almost at the stage where it could turn into the waterproof permeability rating, the breathable waterproof rating of materials. Everyone talks on a slightly different scale. And because of that, I've got together 4 people who know far more about the subject than I do. So I've been able to persuade them to come on, for which I'm very grateful. And whilst the big trend is towards a circular economy of keeping products going for longer, people have rightly been asking, why are we talking about the decomposition of garments? And to me, and this is almost the last thing I'm going to say, there are 2 really easy answers. Where we are right now, we know is bad. Any form of change or movement will be better for us, even if we go in slightly the wrong direction. So we need to get the whole of the mass of the public joining in. So if they understand biodegradability is an advantage, that will get them moving. The other thing is that there will be tangential developments, and I would point towards the Finisterre project with Aquapack, where they have now developed a garment wrapping plastic that is water soluble. So for those 2 reasons, I think we have a very valid panel, but far too much about me. Who we have Dr. Mark Taylor, who the whole of the British outdoor industry knows because of the Performance Clothing Research Centre. Mark is also one of the key people at the Microfiber Consortium with all the plastics in the ocean debate. We have Vanessa Mason, who is the senior vice president, Vanessa, of engineering at PrimaLoft, who are stirring up the whole question of biodegradability of synthetics. We have Kirsty, who, although she describes herself as a life cycler and working towards 2025, she has taught to me so much because, sorry to embarrass you, Kirsty, she is one of the ISPO sustainability judges who has a greater overview of everything going on in the industry than almost anyone that I've met. And finally, we have Daniel. Daniel is the public face of Ventile. And Ventile is also going forward. Now that it's with Stoltz, they're doing other things. But yeah, that's far too much about me. What I wanted to do was start to steer the conversation. And if I could point it towards Mark, can you give us an introduction about your take on the plastics in the ocean, or the amount of plastic waste that there is going around?
So the conversation in the groups I partake in, and this includes the SEN committee that's working on standards for measuring microfiber release, has moved away from it being about plastics and it being about fibres and other textile derived waste. And part of the reason for this is that when you look at any studies where they look at ocean sediments or river sediments or even fibres floating in rivers, you find there's a lot more cellulose than there is polyester.
So there's more natural than artificial, if I use crude terms.
In a recent study from the Mediterranean, there's 7 times more cellulose in the ocean sediments than there is polyester. And bearing in mind that these fibres have roughly the same global usage at the moment, why is there more accumulation of cellulose? It would imply that it doesn't degrade in the ocean like some people think it does. So
now, Mark, I know you have greater insight, and the big growth of cellulosic waste has happened in the last 70 years. Is it presumptuous of me to say, could it be something to do with the dyes being used? Could it be something to do with the fabric finishing? Do we know enough information yet?
No, there's quite an interesting journal article on a shipwreck that was found in the Atlantic, and the boat had been on the bottom of the Atlantic for over 100 years, and they found a cotton waistcoat on it. And I think it's quite telling that they found a waistcoat, and it was a waistcoat. And they took it back to a lab to do an analysis of the amount of biodegradation it had suffered. And the dyed sections had suffered 0% biodegradation, and the undyed sections had suffered less than 2% biodegradation. So dyes can kill the organisms that result in biodegradation, but at the oxygen levels and the dark levels and the pressure due to depth that you experience in the ocean, it seems that other things are at play. So things that biodegrade on the surface, in a compost heap perhaps, or even in a laboratory, appear not to be biodegrading in the natural environment.
Well, for a start point, Mark, you've now just destroyed everything that we learnt at school. And I actually want to go to Vanessa, I know she's going to surprise us about biodegradable polyester. Sorry, I grew up. Polyester is a synthetic. What have you done to it, Vanessa?
So, Charles, I wanted to talk a little bit about, first, PrimaLoft is mostly known for our synthetic performance installations, but we also do fibers and fabrics. And we have a really strong philosophy here at PrimaLoft. It's part of our DNA. We call the philosophy relentless and responsible. We sort of ask ourselves, how do you choose between what's good for your company and what's good for the planet? And we believe that they're one and the same. We try to leverage our advanced material science capabilities to develop and design performance-based materials that are also sustainable. Our belief system is that both performance and sustainability can be elevated, neither one sacrificed. So underneath this platform, we have many sustainable technologies, recycled performance materials, biodegradability, et cetera. What we've done with our PrimaLoft biofiber technology, we basically optimized the polymer, the polyester polymer. We have not changed the polyester. We've only optimized it in a way to make it more attractive to naturally occurring microorganisms to consume it. It's really important as we talk about how to design authentic biodegradable garment systems that designers or brands, they ask material vendors what type of biodegradation is your material offering, because you want to make sure materials aren't fragmenting into smaller pieces of plastics. So we chose a biodegradation technology that's hydrolytic in nature, which means it is not fragmenting into smaller pieces. And when you talk to vendors who are offering biodegradable materials, it's important you always ask, what are the biodegradation byproducts. And in the case of PrimaLoft Bio, the byproducts are methane, carbon dioxide, water, and biomass. And so it's really important that materials being selected for garments that are biodegradable result in these types of byproducts. That means that it's really going through its complete biodegradation process and that it's not just fragmenting into smaller pieces. The PrimaLoft biotechnology that we're using, we test in laboratory environments. And it's really important to note that when you do testing in laboratory environments, these are accelerated tests. And we're required as material vendors, we're required to report the test procedure we're using, the biodegradation rates, and the time frames that we're testing in. So when people are selecting biodegradable materials to design authentic garments, they need to check with vendors, what test procedures are you using, what are your biodegradation rates, and how many days were they tested for. And so I'll just throw out a couple of numbers for the PrimaLoft biofiber technology. For example, the accelerated tests we do to assimilate an anaerobic landfills ASTM D5511. And in that test, we achieved 93.8% biodegradation in 646 days. For the marine environment, we used ASTM 6691. And again, this is an accelerated test in the laboratory. And we're continuing to allow that test to proceed. We're at 74.3% biodegradation in 889 days. So those are the kinds of data that when designers at brands are looking for material vendors that have biodegradable materials, those are the kinds of things, the kind of data you need to ask them for. And we utilize this technology in a lot of PrimaLoft bio insulation products. So we have it in, PrimaLoft gold insulation bio, we have it in PrimaLoft black insulation bio, we have it in our Lux, our blowable PrimaLoft Lux product. And you're also going to see it available, we have it available in traditional fleece styles and in base layer fabrics as of June of 2021. So these materials are coming out. We have also, PrimaLoft has also partnered with Moderator, who is a woven fabric supplier to provide like shell and liner fabrics so that you can start to combine, PrimaLoft bio insulation products with your shell and liner fabrics for garments as well. So
Vanessa, we'll come back to wovens later on, but I think in all the information you've provided, you haven't emphasized that the biodegradation going on is happening in 2 and 3 years. When I look at the biodegradation of polyester, I know it's measured in centuries.
Yes.
If we don't treat it with the best finishes on, we can accelerate that tenfold, so we can measure it in decades. What you've just casually slipped into the conversation is a couple of years. So thank you, PrimaLoft.
Yeah, so Charles, I'm glad you brought that up, because it's really important when you're looking at investigating biodegradable materials. Like as a vendor, if somebody comes and asks me, I should always compare it to the standard PrimaLoft polyester fibers that have not been optimized. These fibers show less, they haven't even started biodegradation yet. By the time that PrimaLoft biofibers have completed their biodegradation cycle. So it's always important to understand how does that compare to standard synthetic products. And Charles, you asked us to think about, how do we standardize the way we talk about things? One of the things I'd like to see our industry or this segment of biodegradable technologies sort of standardize on is what's good and what's not good. My general rule of thumb is regardless of your biodegradation rate, if I'm seeing a material that's showing at least 60% biodegradation in under 1,000 days in these accelerated lab tests, but the standard product that is not biodegradable hasn't even started to biodegrade, they get a thumbs up for me. And I don't care, if my rate is better than their rate, if they've been able to achieve that level of biodegradation, I give them a thumbs up.
Okay. And Vanessa, you also mentioned the ASTMs. The thing I like most about the ASTMs, it's not a perfect test, but it also measures the toxicity at the end of the period of what's left. And that to me is all key, because if we are going to talk about composting, the last thing I want to do is start poisoning the soil. Just 2 presentations ago, we had the whole blown regenerative agriculture side about keeping the biodiversity and the soil health going. But thank you, Vanessa, on that. What I want to do is I want to chip over to Kirsty, who is going to give us an insight to wool. The wool is what was used on those Everest attempts in 1924. It was specified by Shackleton and Scott of the Antarctic. It is the original smart material. Now, Kirsty, can I hand you the stage to tell us about why has nature been able to do so much good?
I think because nature is good, and nature is made good in the beginning. And well, probably the only way to find out find the British people falling down from Mount Everest is because they were wearing the wool. That's how they recognize them. And you may find old Vikings or very old people frozen into the ice wearing their nearly intact wool clothing. So wool is preserved over a very long time, especially then in cold environments. But for me, wool is a gift from nature to us that we are kind of just lending and giving back. It is a gift that the sheep are giving us every year. A lot of people are kind of not afraid of, but they are skeptical to the sharing of sheep, and they're talking about that as an abuse to the animals, but it's absolutely not. If you have seen a sheep that has been out in the wilderness for like 4 or 5 years, escaping, not being able to be found again, it comes back, it cannot walk, it cannot breathe, it cannot eat. So it's really is bad animal welfare to not share the sheep. It's like you going to your hairdresser, Charles. I can see that you do that regularly. So it's they need.
We're not in lockdown.
Yeah, or Mark maybe. Yeah. So we all care for our, let's say, the body, and the sheep are not able to do that themselves. So it's a perfect gift that we can use in a very, very lovely way. And it's also contributing to sequestering carbon. Did you know that one sheep in 1 year sequesters like 2 kilos of carbon?
No, I didn't. Thank you.
So that's actually it's a sink for CO2, which is a natural one. It's part of the biogenic cycle. So it's really nice. Maybe just a little fun fact. And if you,
the fun fact, which you're never going to be able to beat, and my students will tell you, is Otzi was the original caveman who crossed the Alps. And in those days, that he could not go to Timberland to get suitable footwear.
No.
So they have found his reed footwear where he bound his foot made out of reeds. And he had actually put a layer of wool insulation in the bottom of the shoe. Yeah. This is 5,000 years ago.
Yeah.
Full respect to you, Vanessa, but polyester doesn't really have the 5,000 year span. So
I think the mountaineers in New Zealand still use that to put their wool in the shoes, in the walking shoes or boots, because it's also good if you have blisters. The wool will naturally take care of your blisters as well. So it's not just for the insulation. Wool is very good for your skin. I mean, it's a kind of a beauty thing. Or it's also proven that kids with eczema are becoming significantly better when using base layers of wool or sleeping in wool, and we all sleep much better when we sleep in wool. So there's a lot of very functional good attributes to the wool. And
well, to take wool right back to its antibacterial qualities, yes. I know from the effects of the First and the Second World Wars, the wool clothing they were wearing was stopping so much cross-contamination and infection within the soldiers.
Yeah.
So it's always been there as this medical textile, as well as a functional textile.
And also, if you were taking and just like being in the gym, doing sports, or being a lot of people like military, being a lot of people very close together, I mean, you prevent this bad smelling. So you can take off your shoes or keep your shirts from sports, and you still smell lovely. So it's.
So you mean after Zoom meetings, when we finally get to join together, we all need to be wearing wool?
Yes, we do. So I don't know how far you want me to go into wool in general. I could talk for days.
I want to come back to you on wool.
Yeah.
I want to now include Daniel, because Daniel is the new, I say the new face of Ventile. He's part of the rebirth of Ventile. And Ventile was the original material that we all thought was the amazing shell material from a natural source. But not only does that still exist, but Daniel's done things to it. He's made new combinations of material. He's made it lighter. He's changed the coatings on it. So Daniel, the floor's yours for the next bit. Tell us what we need to know about the tightly woven cotton.
Thank you, Charles. Thank you. So we like working with natural fibers. That's for sure. Our main fiber is cotton. Every development is thought about cotton fiber, and especially in terms of we are concentrating for sustainable production. So first of all, it's organic cotton, and then we combine also fibers like hemp and linen. What we also did, or trying to develop further, is recycled cotton. That cotton is extremely sustainable because it has already been grown on Mother Earth. So this cotton is just collected, processed into new yarns, and finally woven and finished again, and in order to reuse it again. But it is all biodegradable. Biodegradability can be achieved by 100% organic cotton, where there is no fertilizer or any other chemical stuff, agents used at producing it. Yeah, and that's what we developed also, from very fine fabrics from 110 grams up to, now we're in organic, up to 240 grams in organic, 100% organic fibers.
I'm very impressed that when you go to pure frozen conditions, like the Antarctic survey team, they're all wearing Ventile garments, because the moment you go below zero, Ventile takes on this additional benefit. Mm-hmm. Now, when we have Ventile in Europe, it's sometimes below zero, it's sometimes positive, it's quite often wet. Mark and I live in England, so we know what the rain is like. Mm-hmm. You have now made Ventile combinations using hemp and linen. What do they bring to the fiber, to the original fiber, which we would not expect from before?
These fiber, we try to keep the characteristics such as windproofness, waterproofness, water repellency, and breathability, first of all. That's the most important thing about these cotton, or about these constructions. So we feel very well inside, and we are protected by the wind and weather and the rain. What brings more? The hemp and the linen, what do they bring more? They bring more like a visual aspect, which looks very natural. So it's even, you see from the first view, that's a natural fabric, and it feels also like a natural fabric, of course. Another positive point is these fibers are stronger than cotton. So the tear and the strength and also abrasion resistance is higher with hemp and linen. So that's a surplus on these combinations.
No, we're all learning from you at the moment, Daniel. I know that if we go back to the end of last year, Ventile got highlighted as the fabric of performance days. I know in spring this year you were across at the Future Fabric Expo in London, and once again you won the prize. So you're obviously doing something to Ventile, which means we've all got to revisit it, because it's not fitting with what we presume Ventile is. So, but now we're on the subject of outers. I want to go back to Kirsty. Kirsty, we've talked about wool as a version of tweed, where the wool is starting to offer, when it was waxed and oiled, we had windproof and waterproof qualities. What can you add to the conversation, Kirsty?
Oh, first of all, did you know that Prince Charles, he buried his tweed jackets and his woolen jumpers? He's the high patron of wool.
Yes,
so he buried them to show, make a showcase of biodegradability in soil. So after the half a year, he dug it up again, and he compared, of course, with some synthetics. So he's very, very keen on showing the attributes of wool. And, you know, in Norway, we use a lot of these sweaters. And they can also be used very well outdoor, like for an outer layer, but not when the rain and the wind sets in. So we've been using a lot of cotton traditionally as well, a little bit like the old-fashioned Ventile. But now it's so much further than the tweed. I mean, tweed is beautiful, and you have still the classical weaves, is wonderful. But they're not so much good for outdoor sports, I would say. But you can have like this. One of my absolute favorites is the fine woven wool that acts just like, or it feels and looks like any kind of polyester synthetic Gore-Tex jacket. It is. I think it's a little bit the same weaving technique as the Ventile, so it's very, very dense. It's very, very wind and waterproof, and it breathes. It breathes much more than a synthetic textile does, of course, because that's one of the main features with wool in general. So this is my absolute favorite outer layer, and this one is especially from Houdini, the Swedish brand, which is really good. Also one of my favorite design brands.
Eva's gonna love you for that plug.
It's so beautiful. So I really, I think it's so nice to see that wool can be used in a very, very technical way. It's very, let's say, high-tech, modern, 2020 kind of textile. And so several outdoor brands in Europe have started to use it for their products. It is slightly more expensive than a synthetic. But the good thing is that you don't leave any microplastics. You don't have any kind of, let's say, negative finishes on top of it. So it stays natural. Well, so the only thing we need are wool buttons and wool zippers.
I want to pull Mark Taylor back into the conversation because Mark is just a hive of information, and he knows what happens to wool when it comes off and goes into wastewater and the sewage process. Mark, can you reveal what you found out by accident?
Well, I wish I could tell you what happens to it, but we think we know. If you study all the papers that have looked at the sediments in the oceans and the rivers, one thing that's always absent, so there's always discussion of cellulose, be it regenerated or natural. There's always discussion of polyester and other plastics, but nobody ever finds any wool. And if you've ever seen wool fibre under a microscope, it's obvious. It stands out like a sore thumb. It looks like wool. It's always wool. So why is there no wool? One potential explanation is, as I said earlier, cotton and polyester share about 35% of global fibre consumption. And with wool, it's about 1.3%. So that could be why. But it could also be that we know for a fact that if you wash your wool in the washing machine with the wrong washing powder, there might not be any wool that comes out of the washing machine because the enzymes in the UK we call biological washing powders, but in the rest of the world you just call washing powder. Those enzymes can digest wool. And a colleague of mine used to work at a major retailer, and for an experiment he put some wool socks in some water with some biological powder in, and within a couple of weeks there was just the elastane left and no wool. So it's likely that the wool is being consumed by the bacteria in the wastewater treatment plants, and that's why it's not making it through to there.
Well, Mark, on top of that, even if you use the right wool detergent to wash your own garment, the moment that wastewater hits the sewage system, we know sewers are full of fat, baby wipes, and an excess of detergent. So,
and the wastewater treatment plants themselves are full of bacteria. That's how they work, isn't it? So the bacteria that's consuming all of the other waste coming out of the house will almost certainly be consuming the wool. We haven't yet been able to prove that. Pre-pandemic, we were planning to, we were promised access to some sludges from wastewater treatment plants so we could start examining them for different fibre types, because at the university there's a student in a different school who's been sponsored by Yorkshire Water, and that's how we were going to get to that. But obviously everything's slowed down, and that hasn't quite happened. So one day we might find the answer to that.
Well, that makes sense. And can I, for the final bit, go to Vanessa? Vanessa, I cut you off before because you were just about to move on to woven fabrics from Amateris. Can you give us a bit more detail? Because I don't think any of this panel are aware of how things are going.
So PrimaLoft, we worked on biodegradable fiber technology, but our hope is, and our anticipation is that in the outdoor industry in particular, the other material vendors will as well. And in the particular case of pairing PrimaLoft installation products, it's to our benefit to have biodegradable woven shell and liner fabrics to pair those installations with. So we are looking to others, we call them co-contributors, where we can share our knowledge about biodegradable technologies and materials, and even share with them the exact technology we're using. And we have partnered with Amateris with their woven fabrics, where we are providing them with the PrimaLoft biotechnology that we are then putting into their filaments that they're using to make the woven fabrics. And so you'll start to see more fabrics that you can pair with PrimaLoft installation products, so that you can move towards a more authentic garment design that is, more biodegradable than if you're not using biodegradable fabrics. So,
Vanessa, I feel you're skipping over an amazing bit of technology again, just because that's the field you work in. To us normal people, you don't appreciate of how wow it is. I can imagine the bio finish on insulation, but when you put it onto a woven yarn, the moment you start to weave, the finish will be rubbed off. So somehow your technology
our technology is not in a finish. We actually optimize the polymer before extrusion. So it's not a topical treatment. It's actually, the polymer is actually optimized. Yeah. So once you extrude the fiber or the filament, there's no ability to rub it off or wash it off.
Yeah. Vanessa, that is phenomenal engineering, but you're just treating it like it's any bit of regular engineering that you do at PrimaLoft.
No, so Charles, you're right. I mean, it took us about 5 years to develop the technology. It was, 2.5 years of doing just research of the science, and then 2.5 years for process engineering. So not only is there the chemistry engineering, there's process engineering. So we had to be able to know that, can we scale this into like commercial bulk extrusion processes. So 2.5 years of process development. And then also a lot of the delay in being able to launch biodegradable products is these accelerated laboratory tests. So they can this isn't just a 2-week turnaround time. This could take up to 2 to 3 years of products being tested in accelerated laboratory environments before you're ready to go to the marketplace with a biodegradable material. So there is a lot of knowledge and science that went into developing the technology. And we're trying, like in the case where we partner with Amateris, we're sharing all of that with them so that they're not delayed 5 years coming out with woven fabrics. So we're able to accelerate the ability of Amateris as a co-contributor to the outdoor industry of sustainable materials. We've partnered with them in that way.
So by way of summing up this panel, I think, Vanessa, you've made a brilliant case that we can now get a face fabric which will biodegrade or compost down really fast. Kirsty has showed us wool has actually become more technical. So we've always known about the biodegradability of the keratin product, but you're showing us examples of how it's now performing in a more desirable role, whereas Daniel has taken something that was developed almost a century ago, and you've shown that not only has it become more modern, but it's got enhanced features as well. So right now, I'm hoping the people listening to this webinar are suddenly going, we know the insulation can compost down, but the thinking was, certainly a year ago, if you had a biodegradable jacket, you almost had to slit open the face fabric to let the microbes in. But now we've heard from PrimaLoft, the microbes can get through. We know that wool is now more performance orientated, and Ventile has even become better enhanced. Now, on this subject, we've got the ASTM. You quoted 5511, and there's also 6691 on the compostability or the biodegradable in circumstances. It's interesting how we're all going to an ASTM and not an ISO rating. And the more that I talk to people in fabric development, they say the ISO rating does not work, is not suitable. And as I described at the start of this, my big worry is that we will end up like waterproof, breathable textiles. Everyone starts to talk on a slightly different scale, so things are very hard to compare. So, Vanessa, if I come back to you and I say, you started on this earlier, what are the parameters that we should be trying to encourage an ISO rating to work to? In your mind, what is the most fair or level playing field for comparison?
So it's really important, first, Charles, like biodegradability and compostability. Like, for example, PrimaLoft biofibers, the polyester fibers, are not compostable. Mm-hmm. They are biodegradable according to the ASTM test methods, but the ISO methods that I've seen, like from Hohenstein, they're about compostability. And there's even different levels of compostability. Is it industrial compostability? Is it residential compostability? And
well, we're adding oxygen, we're adding pressure, yes, we're adding heat.
Correct.
There are all these variables.
Yeah, and so a lot of the ISO methods for compostability, they're targeting like 90 days compostability in industrial compost environment. So it just depends on, there's also laws and regulations around what type of biodegradability claims companies can make. And it's actually, we have to make biodegradability claims based on where our products will end of life. So for example, you don't really find garments in composts. Maybe 10 years from now, that will be the culture or the technology of how you dispose of textile apparel. But today, we have to report out biodegradability in the types of environments that my product might end its life. So that's one of the reasons why we selected ASTM 5511 and 6691. So because my product, like it winds up in apparel, and you don't usually see apparel in composts, yeah, we cannot make any marketing claims around compostability. So like when we talk about test standardization, we also have to make sure that we're selecting environments where the apparel products will wind up in at their end of life, whether it's going to landfills or it's like accidental exposure to the environment via, laundering into wastewater systems or into marine environments. We have to be conscious of that.
Well, that starts to make a clearer picture. Kirsty, what would you like to add to this whole question of measurement of how fast it breaks down? We've heard from Mark. Now, I know the sewage system takes less than a fortnight. So, Kirsty, you've potentially got a fibre that when mixed in a sewage system is going to disappear within 10, 15 days. If we're going to advise the ISO team on what regulation or parameters they need to have, what would you like to add to the conversation?
Well, first of all, it's nice to know that it deteriorates very, very quickly in the sewage systems. It goes slower in, let's say, marine environments or in the soil. It's a rather slow degrading material. The wool industry doesn't have any common take on this standardization yet. It's not a topic that has been very much discussed so far, because it has been, well, wool is biodegradable, so it's a very new topic to the industry. So there is no common take on it. I find that the biodegradability as such is sometimes getting into the greenwashing, because it's as long as we don't know how. I'm not so much interested in the time aspect, because that could be different positives as well added to that. But the systems related to it. So I'm personally, I'm very interested in industrial composting as a solution in the future, because I think that is, because it's not obvious that I'm throwing my sweater in my own garden. That doesn't work that way. But what is interesting with wool is that when it biodegrades, it becomes a lovely fertilizer. It has a lot of rich nutritions. So the industry in wool is very interested in getting seen for, or getting those advantages out there as well. So when my sweater is worn out and it either biodegrades over time, or it is in an industrial compost, it can come out as like fertilizer pellets that you can use in your garden. So it's more, I am as usual more on the qualitative side.
Be proud of that. Daniel, if I turn to you with the Stolz fabric, if we're going to talk about a standard for biodegradability, what would you like to add to the conversation?
But just focusing more on organic fabrics, on organic cotton, organically grown cotton without use of any chemical agents and helps. So that's from the raw material. But what we have to make sure also that the dye stuff being used is also biodegradable. And that's what I understood is still not resolved 100%. And last of all, also, of course, the impregnation, the DWR on the fabric we're using. Of course, we're using nowadays PFC-free DWR. And that one, according to the producer, is biodegradable at 70%, 70.
Okay.
Which is not 100, but at least it's 70% biodegradable. So that's the best what we can offer at the moment. We're working on better solutions. We want to go 100%.
Okay. Well, I mean, that's a really clear statement. If we have any of the chemical companies there, we want a 100% biodegradable DWR. It's a really good conclusion.
Absolutely, and it's feasible. We are close to it. Actually, there is agents on there. There is a solution, but it's not good enough. So people are expecting a kind of waterproofness, a minimum they want to have. They want to have the protection. So existing solutions, PFC-free, which is 100% biodegradable, are not good enough now. They don't give enough protection to the wearer. So that's where we are at the moment. So, but we're still developing on this.
Well, I've heard. Well, it's not the question of hearing. I know that Patagonia's investment fund, Tinshed Ventures, put over $1 million into the Swiss company Beyond Surface Technology to investigate this area. And when they reported to ISPO 2 years ago, they still hadn't been able to do as much as they wanted. They'd made progress, and being the Swiss people, you know the process is qualitatively done, but they still hadn't achieved everything. So I know as an industry, we are waiting for that. But the easiest way to clear up standards is, of course, to turn to the guy who sits on top of all the testing, which is Mark. Mark, if you had an opportunity to instruct the ISO in this area, what parameters would you put to it?
So it's quite a complicated area, isn't it? So Vanessa testing to ASTM D6691, which is basically anaerobic conditions, but in solid environments. So it's like a simulated landfill site. And ASTM D6611, 6691, yeah, is a marine environment.
6691 marine and 5511's for land.
5511 is land. 6611 is marine, but in aerobic conditions.
No, 6691
is, yeah, sorry, Charles. Okay, so 5511 is, so it's a semi-solid environment. It's simulated landfill. It's anaerobic.
Okay, yeah.
And 6691 is a marine environment, but it's aerobic. And so, I mean, you've got to think about the end fate of the products. Some brands, I won't name them, they test compostability to EN 13432, but that's a packaging test because there isn't anything better. And the point at which the thing has passed is when 90% of it will pass through a sieve that's 2 millimeters, with holes of 2 millimeters. Well, as a man researching microplastics, I'd say you've decided it's disappeared just at the point it's become a real issue to the rest of the environment. So these are the sort of things.
Everything Vanessa said about the microfragmentation does not apply because that's actively encouraging the fragmentation.
Yeah, the compostability standard is, in essence, testing its breakdown to a point where it'll pass through a small sieve. So is that really compostable? You need, well, obviously there are different ways that these standards can work. And so the STM ones, I believe, are looking at CO2 evolution in the test canisters with the simulated environment, and you compare that to a stand. You've worked out how much carbon there is in the product. Vanessa, correct me on this, but you look at how much CO2 might evolve, what's the maximum it could, and then you work out how far down the route you are based on how much is evolved. But
that's correct. Yeah. So the accelerated test in lab that we're using, they're looking at the off-gassing levels of it.
If you read those standards, they do make some claims in there that you should never get 100% because some carbon ends up in other things. But you can get close, as you've been getting close. What else? I mean, really, somebody needs to sit down and have a think about what's required either by the industry or by the regulators. And I think this will come back to more towards regulators than the industry in the long run, and work out what it is they want. Because I mean, I don't know about the ISTM standards, but most of the other ones that people are using, the ISOs that are used and the EN standards that are used, these are basically packaging standards that have been adopted for use because there isn't anything more suitable. And I know I've spoken to a major cellulosic manufacturer, and they've tested to the EN standard I mentioned, got some really positive results, but they hadn't realised that basically it was possibly contributing to the problem. I most of my work's on microfibers, but the garments aren't chopped up and thrown in the ocean very often. So we're looking at other ways it gets there, whether that's through laundry or just wear and things. And I think most garments will either end up in incinerators or landfill sites, won't they, at the end of their life if they don't get recycled. But Kirsty made an interesting point about industrial composting. We know that consumers don't understand the difference between industrial and domestic composters. If something says it's compostable, that means you could put it, in your compost heap in your garden and feed the worms, and they don't appreciate the coffee cups and stuff that do compost in that environment. So there are some big issues around using compostability. But we ought to be encouraging recycling, reuse and recycling more than priority optimizing the destruction at end of life, shouldn't we? But I mean, it is great. I did want to say I spoke to some people from PrimaLoft a couple of years ago, and I was saying that your insulation product's fantastic, but once it's wrapped in Pertex, it'll never biodegrade, will it? And I was promised that these biodegradable shells were coming, and it's really positive to hear that we're getting close to seeing those, because that will be the big stepping stone towards making a biodegradable polyester garment entirely out of PrimaLoft.
Well, point taken on that, Mark. I think as a group of four, well, there are five of us, we've all got a vested interest to whatever standard comes out. And although you're saying leave the standard to professionals, I'm getting the impression that industry should still continue to lobby, because there are these micro changes which are not being answered by the current standards. So,
I don't think I said leave it to professionals, but just an anecdote. Well, yeah. I was at a conference many years ago to do with firefighter protective clothing, and there were one bloke from the firefighters union got up and he said the problem with standards for firefighting garments is the UK committee has 24 members, of which 2 are serving firefighters, and all the others represent manufacturers and test houses. Yeah. That's the problem with standards. The people writing them have a vested interest in making money from them, and that's not how they should be being written.
Point taken. Very, very succinctly put. Now, would anyone else like to add any other comments, or can we finally return to Astrid and actually see if there are any external questions which have been asked? Because this has been a really in-depth discussion. It's gone into far greater depth than I thought it would go, and I'm really proud that you guys have been able to keep it understandable. But any of the rest of the panel like to add something to it?
Yeah.
Hi.
Yeah.
I have a small thing that I wanted to add to, which probably Mark will be very interested in as well, because there's recent research in New Zealand has shown that even what I would consider problematic superwash treatment of wool, which is a Hercoset treatment, a very thin, fine polymer layer outside of the fiber, that biodegrades readily with the wool, even quicker than the wool without treatment, and doesn't leave any microplastics, because we were very afraid of and very excited to hear the results. So superwash is not the big ghost that we thought it would be.
Do we know what the feedstock is? It PLA? Is it from cornstarch?
It's a polyamide.
It's a polyamide. Oh, right. Okay.
So it's. I think the synthetics or the plastics are sometimes very difficult to understand. So thank you, Vanessa, for explaining a little bit more.
Okay. Well, finally, I think we can return to Astrid just to see, to close the day.
Okay. Hi. Hello, Charles. So I would turn to some questions. I will follow. I will.
Would you like to read out the best 2 or 3 questions?
Yeah, okay. One question is for shoes. I have from Paul. Is anyone working on compostable material for footwear? In Europe, composting plants do not accept clothing, only packaging and food waste. Where can biodegradable clothing be composted?
Good question.
Yes.
The next question is?
Okay, Andrew, the answer came from Flo from PrimaLoft. Then we have, what is your opinion for the most sustainable fabric for swimwear?
Oh, good question. And is there a third question that we can address?
Let me see. What is the best way to treat biodegradable synthetic fabrics with water repellency and still maintain the biodegradable properties of the fabric?
Good point. So for my panel of 4, who wants to volunteer? We've got 1 on footwear, 1 on swimwear, and 1 on finishes. Who would like to say something?
I'll say something on footwear.
Thank you, Vanessa.
So PrimaLoft, we do offer needled PrimaLoft bio insulation for use in footwear, but the question is a good one because there's many different material components in footwear. Insulation is just one of the many. So how do you find all the different components of footwear to make an authentic biodegradable footwear? And really, I put that back on the designer and the brands, that they have to go back out to all the material vendors and start educating about biodegradability and asking them, please work on biodegradable materials. So the pull needs to be with all material vendors contributing to those footwear pieces. I made a comment earlier in the conversation about how when you make biodegradability claims, they have to be based on where your product might end its life. And today, apparel and footwear, they're not going to compost environments. They're not going into industrial compost environments. And I actually do not know of any today that are supporting the use of, supporting composting of apparel. So that's one of the reasons why we avoid composting claims. But I do believe it could be a wave of the future. So, within 5 to 10 years' time, could we have a culture shift where it makes more sense and those industrial composters are now outfitted to manage the composting of apparel products? I think there could be a cultural shift coming in the next 5 to 10 years. So I think it's coming, but it's just not available today.
Well,
I'd add to that, Charles.
To make sense. Mark, you were going to say.
I said I'd just add to that design. I mean, Vanessa's right. It comes back to the designers. These products need to be designed to be easily disassembled, don't they? Whether it's the microbes threads developed at Leeds that mean garments fall apart if you microwave them, or some other way so that you can easily extract the components. So the sole and the insole and the upper and the insulation layers, and they can all be handled separately. I also have a concern over composting as a long-term solution. I think somebody mentioned earlier what the byproducts of composting are, and they tend to be methane and carbon dioxide. And the methane might go off and get burnt, and that's even more carbon dioxide. So things that were carbon sinks suddenly become carbon sources. So it may not be the best solution.
Okay. I'm really glad at the start I said this panel will not give a definitive answer to how to solve life. We're just highlighting what the problems could be. So we've looked at a bit on footwear. Can anyone contribute something positive on swimwear or on the finishes?
I'd suggest for swimwear, you'd go back to something I mentioned earlier, that if you choose the right nylon, which becomes infinitely recyclable with no degradation in performance, you can get all the benefits that synthetics bring to swimwear that I don't think many naturals can. I mean, obviously, we've all seen pictures of woolen swimsuits that used to be worn in the 1920s and 30s, but I'm not sure anybody would wear those these days. I think
you could crochet one.
Well, yeah. I think there are certain areas where synthetics really have created a niche that's going to be very difficult to kick them out of, so I think you need to be looking at perhaps a biodegradable polyester type fabric, maybe adopting one of the shell fabrics or a knitted fabric that PrimaLoft have been working on, or taking something that's infinitely recyclable like the right nylons.
Okay, sound. So the third question, can we add anything further to what Daniel highlighted already about the finishes being how they can progress, or is that a question we're going to have to pass on?
I mean, do we know? How important is water in biodegradation, and therefore is DWR so important? And if they end up in either a wet or a dry environment that's probably got some moisture in it, it will probably permeate past the DWR anyway, because DWRs are relatively easily defeated with pressure. They're designed to repel raindrops, aren't they, more than anything else? So it may not be such an issue unless, of course, they retard the biodegradation process somehow.
Good point. Anyone else want to add something extra?
I'll just add something, and I'm adding to a comment Daniel made early in the conversation about how we need more work done in the area of biodegradable dyes and biodegradable finishes. So it's my opinion that we've been focusing on where's the low-hanging fruit, and the low-hanging fruit was the majority of the material is the polyester. So let's focus in on the polyester, but more work needs to be done in the area of biodegradable technologies for dye stuffs and finishes. So,
well, on that note, Vanessa, if I ask you, all four of you, to come back in 2 years' time, can we have this session again and see what has progressed? Because what we've done is that we've clarified the situation. I think we've highlighted there's not a perfect answer, but there are a lot of things moving in the right direction. So semi-seriously, I'd like to invite you all back to Performance Days in 2022, and we'll try and rehab this conversation to see of progress.
That could be really interesting, because I think we've seen some big strides in the last 2 years from some brands.
Exactly. But if we go back to you, Astrid, because otherwise you're going to be complaining about going home.
Thank you. Thank you for this very, very interesting discussion. So maybe you join us tomorrow when we have the Sustain and Innovate conference. So thank you so much for this really good panel. Thank you, Charles.
Don't thank me. It's the 4 specialists I've got. They're the people who made the panel. Okay. So bye. Have a nice evening, all of you.
Thank you. Bye-bye.
Bye.